Okay, so the big deal here is we need to use a graphing calculator. So I actually have my TI-84, my TI Nspire, and I'm going to show you how to use Desmos Online to do this quickly as well. So I'm going to do all three. If at any point today, while I'm using the calculator, if you need me to go back to something or you didn't catch something, please, please, please unmute yourself, interrupt me, and ask. Okay, but remember, I'm going to use 3 different graphing utilities to do this. Okay, all right, so here we go. Again, we're going back to lesson 7.6. I thought it was important that we catch up on this. So using your graphing calculator, state the intervals. Remember, intervals, we're using interval notation, and interval notation is looking for x values. And I want to know where the function is increasing and decreasing. So I think the first thing we should do, sketch the graph. And that's what we're going to use our calculator to do. So like I said, I'm going to start with an 84, but I'm going to do this on an Nspire as well as Desmos for those of you that don't have access to a graphing calculator at home. So I'm going to go to my y equals, and I'm going to type in x to the 4th. Get out of the exponent before you keep typing. Plus 3x to the 3rd. Get out of the exponent. Plus x squared minus 2x plus 1. Again, I saw a few of you just pop in here. For those of you that just joined us, we are finishing our notes from section 6. Okay. All right, so I'm going to hit graph. So here's my graph. It's this tiny little W looking thing here. And you know what? If we're going to sketch it, I think it might be helpful if we make our window graph this window. So I'm going to hit my window button. And it looks like my x's are going from -3 to 3. I'm going to keep my x scale at 1. That just means it's going to put a tick mark every one. My y's, it looks like it's going from about -1 to 4. Oh, I keep going backwards. And I'll leave my y scale at 1. So I just changed my calculator's window to match the window on the paper. Okay? So I think I'm going to go ahead and try to translate this as best I can. I made sure to leave that x scale as a 1 so that it's easy for me to kind of estimate. So I'm going to take this shape and I'm going to put it on my paper. So I think the turning points are important. It looks to be at like -2, 1. It's not exact. This one is like -1, 2. Again, not exact. And this one I'm going to say is like 1/2, 1/2. Again, I am not using exact values. I'm just eyeballing it so that I can sketch this on my paper horribly. I know I'm trying to do my calculators in the way. I just tried to use those so that I could translate what I saw on my calculator onto my graph. By the way, we don't actually need to sketch the graph, and some of you will be okay with this. I just thought a lot of us would be more comfortable if we could draw on this graph. Okay, so we graphed the function. I just kind of moved it over to my paper. And now I'm going to go back and answer it just like we did the slide up here. Right now that we have the graph, we can go talk about where is the graph increasing and where is it decreasing. So I'm going to use, I have colored pencils again. I have my increasing, I'm going to do in pink. I'm just going to go and highlight my graph where it looks like it's going uphill. Just highlighting. And maybe I'll use, I have a green pencil here, so maybe I'll use green to say when it's going downhill. And again, I'm just trying to do this so that you can see it best we can here. Some of you are going to be fine without doing this, but again, I think a lot of you prefer or found it helpful to translate this information down to the bottom of your paper. So just kind of show where it's increasing and decreasing, because then it starts to resemble that number line that we really like. Okay. So at this point, we're really saying if we want to write these intervals, I need to know what this x value is. I need to know what this x value is. I need to know what this x value is, right? Because when we use interval notation, we need x coordinates. This is where the calculator is going to come into play. I eyeballed it here, but I don't actually know where they were. So again, I'm going to start with the 84, but then I'm going to do the exact same thing on the Inspire and on Desmos, okay? So, sorry, I keep moving this in and out of the way. Where I change from green to pink, that turning point, remember, that's what we call a minimum. When I change from pink to green, that turning point, that's a high point, right? This point is higher than the points on either side of it, so it's a maximum. And then this turning point here is another minimum. It's important that we recognize that that's what those are because we need to tell the calculator that that's what we want. And again, please interrupt me at any point if something's not going so well. All right, so here we go. I need to go, I'm going to do them in order. I need to go find this minimum. And there's a way to do that. I'm going to go to my calculate button on my calculator. I'm going to hit second, calculate. So I hit my second button and then my trace. I'll write this down. Oh, look at that. It's giving me the options for a minimum and a maximum. The first one is a minimum, so I'm going to go down to number 3. And I'm sure you did this in Algebra 1 and in Algebra 2. But I want to go find this minimum. Right now it's saying, what's your left bound? Well, okay, so that means I need to go to the left side of that minimum. So I can arrow over. I know this is time consuming. We can also type in a number. So I think we can all agree that I'm on the left side of that low point. It says right bound. So I'm going to move my cursor to the right side. And exaggerate. Don't, stay so close that you can't tell. Like clearly, make sure you're on the other side and hit enter. And now it says, do you want to guess? And I always say no. And so it thinks for a moment, and then it puts the cursor down at that low point, and at the very bottom, it gives me my coordinates. Which coordinates am I interested in? I only, for this question, need the x. Remember, we said intervals are x values. So this is x equals negative 1.826. I know I'm writing kind of tiny because I didn't leave myself a lot of room. Again, for those of you that have an Inspire, I'm going to do it on the Inspire. For those of you that don't have a graphing calculator, I'm going to show you how to do this also. Next one, I need this x value. I need this maximum. I'm going to go back to my graph. I'm going to go back to that calculate menu. So second trace, but this time I need to go down to number 4. But it's the exact same 3 questions. So they want to say, get on the left side. So here's the maximum. Put your cursor on the left side. Hit enter. Then arrow over. Make sure you're on the very right side. Make sure you've clearly gotten over that hump. And hit enter. Again, I'm going to not guess, so I hit enter again. And at the very bottom, it gives me both coordinates. I just want the x for what we're doing today. And it's negative 0.776. Sorry for squeezing that in there. And then we'll repeat that process for the minimum, okay? I'm going to switch calculators to show you how to do it on an Inspire. So I've already graphed my function. I need to change, I don't need to, but I think it helps. I'm going to change my window here real quick to go from -3 to 3 and then from -1 to 4. That's what I was starting to do when everyone kind of popped into class. Okay, so same graph, same window, different calculator. All of us are still trying to find this point here. We just hit different buttons. On the Inspire, we're going to go to menu. Sorry, move it up a little bit. We're going to go to menu. And then number 6 says analyze graph. It's the same 2 questions, just a different number. So this one, yet again, is a minimum. So I'm going to go to minimum and hit enter. And by the way, it's the same questions there, just phrased differently. Instead of saying left bound, it says lower bound. Use your mouse and just click it when you're on the left side of that minimum. And now it says upper bound. I'm just going to drag my mouse over. And you want to drag it until you are clearly on the other side of that low point and hit enter. It plots that point for us and it gives us the coordinates. Again, I only want the x coordinate, so 0.353. Okay, so again, I'm going to write this down. On the TI-84, to find a max or a min, we are hitting second, and then trace. On the Inspire, for those of you that have this calculator, on the graph screen, we hit menu and then number 6. Okay, that's how we find maxes and mins. Find maxes and mins. Okay. Before we do anything else, for those of you that don't have access to a calculator, I'm going to present my screen. So if you have me pinned, you're going to want to unpin me so that you can see this. But I'm going to pin my Google search here. So for those of you at home, and by the way, someone unmute yourself and let me know if you cannot see this. I just went to Google and typed in DESMOS, Desmos, or you can go desmos.com. Okay, so we should be right here, graphing calculator. Just click it, and it brings up this grid, and on the left, you're typing in your entry bars. So I can type in x to the 4th. Now, as I type, it's going to start to graph. Those of you that have been using Desmos know this. To get to the 4th power, just hit your caret. So shift 6 and type in your 4, and then get out of your exponent. Plus 3, whoops, yep, x. And then again, I'm going to get my caret to the 3rd. And it's changing the graph as I go. Plus x caret 2, minus 2x, and then plus 1. And you can hit enter, and it puts that graph right there on our paper. You can change the window if you want. You can scroll to zoom in. You can scroll back to zoom out. That's up to you. We want to find the min, the max, and the min. Click on your graph, and it hands you everything you need. I just clicked on the red graph, and now it shows me 1, 2, 3, 4 coordinates. They're in gray. It shows us those coordinates, those coordinates. This one it thought was important because it's a y-intercept, and then it shows me this one down here. So, and I'm just going to go ahead and change this to a negative. And I know I just changed the graph. But once you click on that graph, it will show you any x-intercepts, y-intercepts, and then maxes and mins. Okay, so I know I changed the graph, but I'm just kind of showing you. You can move things around, zoom in, move back. Once you click on it, it will show you important coordinates. Okay, and some of you are going, whoa, that is so much easier than the graphing calculator. Well, I absolutely agree with you. It is easier than the graphing calculator. But we can't always use Desmos. You know, college professors may not allow you to use Desmos. The SAT, ACT doesn't allow you to use Desmos. So we do want to know how to use our graphing calculators, okay? Okay, I've been talking a lot. Let's finish writing our answer and then we'll pause for some questions. So now that no matter what device you have at home, you can use, you can find your maxes and mins. Now we can go ahead and write our intervals. Remember, my increasing was pink. So I'm increasing from negative 1.826 until I get to negative 0.776. And then I am increasing again from 0.353 on forever to infinity. And I'm decreasing everywhere else where it's green. So negative infinity to negative 1.826. And then I'm green again from negative 0.776 to 0.353. It's just more cumbersome, right? The idea of when is a graph increasing and decreasing, I think is going very well for most of us. But once we put that calculator in and we just have the you know, it's just type consuming to type in the function, find the maxes and the mins, write them down, right? But other than that, the procedure, I mean, you know how to do increasing and decreasing. We know how to use interval notation, okay? Whew, all right, so I'm gonna pause for a moment. What questions or what things would we like to go back to? Are there any calculator questions? Anything we wanna look at there? Okay, I'm going to go ahead and flip my paper over. Okay, we're still in lesson 7.6, but the last slide we did not get to touch either. Okay, All right, so we're still talking about increasing and decreasing, concave up, concave down, but this one's asking us to sketch the graph. Okay, well, some of you will get very overwhelmed with something like this, kind of like when we were doing this with limits. You just kind of like looked at all of the information, you go, I don't know what graph that is. Well, we shouldn't. It's not necessarily a parent graph. What I would like you to do is just start sketching lightly with your pencil. They want the graph to be, first of all, they want it to be continuous. So we want to make sure that there's no breaks in the graph, right? And they want it to be a function, which means it has to pass the vertical line test. The VLT, I just made that up. The vertical line test. Okay. They want our graph to be increasing from negative infinity to 1. Remember, this is interval notation. So on the bottom of my graph, from negative infinity to 1, they want me to be increasing. And then decreasing from 1 to infinity. All right, so very lightly with my pencil, I don't know where to start. I don't know how steep to go. So let's just sketch something in there. Let's go uphill until I get to x equals 1. And let's go downhill after x equals 1. Just very, very lightly with my pencil. I just want to be increasing. And then at x equals 1, I switch to decreasing. Now, that's not my answer, but that's just going to allow me to say, check, check. Now I know the kind of global shape of my graph, direction, okay? But now is when I'm going to go in, and I'm just going to go in with my pen so you can see it a little bit brighter. And now I'm going to just talk about how it curves. They want me to be concave up from negative infinity to negative 2. So here I'm going to grab a Post-it note. From negative infinity to negative 2, they want this graph to be concave up. Remember, concave up looks like a cup. Now, we're not going to draw the whole cup because the whole cup, remember, would be decreasing and increase. I don't want to decrease. Remember, we're supposed to be increasing. So just make it smile a bit, right? We don't want it to be linear. We just want it to be happy. I'm not focusing on y coordinates. I don't know what the y coordinates are. I'm just drawing a graph. We're not all going to get the same answer. All right, so I got my concave up, and now they want me to be concave down everywhere else. So if it helps, take your scrap paper and cover up what you did. And I want to go up then down, but I want to be frowning. So I need to uncover this so I can see where I left off. So I left off here. I want to be increasing but concave down. So I want to increase and be sad until I get to 1. And now I need to change direction. So I'm going to decrease, but I still want to be sad. I still want to be frowning. And I'll put a little arrow up both ends there. Okay. So is this a parent function? No. So could I have read all 4 of these things here and said, oh, I know exactly what graph that is? No. So what I did was I just lightly with my pencil got my directions in there. And then I can go back a little more with maybe your pencil still, but being bold, and just start to put in the curvature. And you know what I'm going to do? I'm going to take my pen and just mark here at negative 2. That's where I had a change in concavity. So inflection point. Remember that word, that inflection point is where does your graph change from smiling to frowning? Okay. Now, I know you had one like this in your homework, and I don't think anyone asked about it on Thursday, but we were already short on time on Thursday, so we didn't answer everyone's homework questions. So maybe that will help if that's one that you struggled with a little bit. Okay. Awesome.